Okay, here is the speed run of the Pipemare Excel Esports case. Like Pipe Dreams, only a nightmare, so it's Pipemare. I'll be using some lambdas and VBA that you can download at a link in the description. The first level here is kind of a straightforward XLOOKUP with just this, we might have to switch whether we're looking in the connect to or connect from. But, other than that, it is, as usual, pretty straightforward. So I'm going to make some named ranges for lookup purposes. That's pipes. That's to. This is going to be from. I know I need these headers to look up on. So I just look up these pipes on pipes, returning 2 for the 2 one. And of course, those have to be concatenated as said in the instructions. Then the same thing for the from side. Then I look up the correct one. And that should be it. I can't use my done button because the VBA assignment will make them all numbers, which I don't want. So I'm going to keep them as strings that way. Now we're going to do a very similar lookup, but we got to multiply by this mask here, right? This bitwise and, right? Which instead of using bitwise and, I'm just going to use my string to array function, which does the same thing. Multiply. All right, so concatenate. Not going to concatenate anymore. Just going to look these up. I'm going to line up the pipes correctly. I'm going to make these into one column, right? Because then I'm going to pull out each one to the side using string to array. All right, all string to array does is just takes every character, turns it into an array. All right, so now this I multiply by the row version of this, just puts a binary mask on the whole thing, right? 2-row string to array of that, right? And that leaves the legal connections that are left in that direction, right? So for, no, this, some this way, right? Because then I got to look up which one of them, whether it's from or to. So that's the to version. This is the from version. And then I can look up, whichever one I need, which is what the question requires. All right, level 3, I'm going to start with, I'm going to make a lambda to see if 2 pipes connect or not, right? I'll call them pipe A and pipe B. And I want to get like the zeros and ones for whether they connect or not, right? So first I've got to look up the connections for the first one, right? So connections for A is going to be XLOOKUP of pipe A on the pipes returning on the 2. And then for the connections of B is the same thing, but I'm looking at pipes B on the from. Now for the connection directions, right? It's just multiplying those together as arrays, right? Like a bitwise and string multiplication, array multiplication. All right. That should be about right. That actually is multiplication, right? That's a legal lambda now, and I can feed it my 2 pipes, and it tells me what direction is allowed between them. I only care about right for this one because I can't move them, and this is a right connection, right? So if this, then yes, otherwise no. Right. I need the same lambda for the next 2 levels. So I'm going to stick it in the name manager here. Pipe connection. It's here. So now pipe connection between here and here. All right, so this is what? Up, down, left, and right. So what? The maximum of these is whether it has a vertical connection. The maximum of these is whether it has a horizontal connection. So if what? The sum of these is 2, then that means it has both, which is represented by a D. Another possibility is it has neither of those, in which case it is an N. Another possibility is what? If I33, then that means it's a V. And then otherwise, the only possibility left is an H. So hopefully that long ifs and my lambdas and stuff are all right so far, and they are. All right, so now we're going to do pipe connection from this pipe to this pipe. One doesn't connect out anywhere. It's only 2 and later that connect. So maybe they don't connect, right? This is a 0, so they don't connect. So I sum these up across there. And then if this has a connection, right, then I don't print anything. Otherwise, I print the number that is breaking, right? And then I concatenate all the broken ones together to get a string, turn that into a number. And then that is level 5. Now, string to array for this, string to array of this. And I need to know the numbers, right? Because that's going to be my answer, is which one does it break at, right? First one, so what is blocked? There's some direction I can't go. And then what direction do I go is the movement, right? Nothing's blocked in the first one because the first one's always unambiguous, right? So pipe con from A to B is there, right? So now I need arrows to pick the direction, right? So I'm going to grab these arrows from over here and bring them here. And the arrow's got to be in the right order, right? Which is up, down, left, and then right, right? So I filter, well, hold on, I want to give them a name first. So I'll call these arrows in that order arrows, right? So now I filter the arrows by what connection is allowed, and I get the correct connection. The next time something's gonna be blocked, because if I move down, I can't move up next time because that's just going back and forth between 2, and that's not allowed. Right? So I can't do the exact opposite of this arrow. So I rotate it by 4 to get an arrow that is not allowed. So now this is possibly my answer, but it might be 2. There might be 2 arrows here, right? Because sometimes there's 2 connections. So what I got to do is we're going to call this the possible connections, but I got to check this blocked arrow. And that's the part I couldn't figure out during the live connection. It's like you can't just go back and forth. All right, so I got to filter out the blocked arrow like this. So filter. Well, hold on. Possible one was good the way it is. All right, so if I let possible be equal to this, those are the possible locations. Now the actual location is going to be to filter the possible ones where the possible ones are not equal to the blocked one. All right. And then I got to close all my parentheses. I never did that, which is probably bad. All right, so hopefully now we've got this. Then if the filter comes out with nothing, that means that our pipe broke and the water spilled everywhere, which sounds bad, but it's the answer to our question because it's where does the pipe break? Where can you not connect anymore? So you look up broke on here, returning on here. stroke on here, returning on there. All right, quick check of 5 and 6, looks good. All right, so now level 7 is from the map, right, which is here. So I just use this to avoid any indirect action. I can use that as a lookup. So now address starts like this. So the pipe is here, right? So I look up the address on here, returning here. So now I need to know, I'm going to look to see first if there's any block directions. At the beginning, there's not. So now I need to know what direction do I go from here. And the first time, I mean, I don't, all I have to go on is it tells me, right? So filter arrows based on string to array of this, right? So that tells me which way I'm going. Now I cannot just reverse next time, right? So I rotate that by 4 to get the blocked arrow. I need the new address, which I use, you know, arrow rotate, or what's my arrow move called? Arrow move. Arrow move. So if you start at Q4 and you go that direction, that's where you end up. That's the pipe. Now for here, it is very similar, right? So I got to start with looking up the pipe on the pipes, returning the 2, right? Does that sound right? Yes, that sounds right. And then I've got to, you know, put that in a string to array. Now notice there's 2 of them here, right? So I got to start by, I got to filter the arrows by this, and that's going to give me 2 arrows, but one of them's blocked, right? So now, so these are the possible arrows, and I'm just using a let here so I don't have to have this function twice. So the possible arrows, so now I filter again, right? I filter the possible arrows where the possible arrows is not equal to the blocked arrow. All right, it's parentheses in the wrong place as usual. Hopefully this is level 7. Let's see. Yeah, this looks like level 7 to me. All right, I'm gonna use X to call just to clean this up because I didn't put a error handling there, so just do it that way. Count if in this array I'm supposed to be counting this pipe. Okay. And that is all the levels. Now we're gonna play a bonus game, right? So for here, you know, how about I just do count if the pipe maze locked is this, right? So that excluding those, I just want these. So add all those together. Looked in the bar, it said 1777. How many connect to the right direction in levels 1 and 2 only? So here's all my games. Here's the pipes in levels 1 and 2 only. Going to do a frequency table. And then I just eyeball it, right? That one goes to the right, that one goes to the right, that one goes to the right. Add those up, 104. How many potential connections? This is actually easier than level 4, right? Because level 4, I had to recode it to like HV, or now I'm just adding it together. So this is bonus 3. That's just the sum of the number of connections, right? Turn what if on, add them up, 17. Okay, I'll do this. I'll do number 4 last. For the hidden message, so I'm gonna create this. This is bonus 5 now. I'm gonna just take all these addresses. I don't care about the pipes anymore. Now I care about the addresses. But I don't care the addresses are in. I only want the addresses themselves, if that makes any sense. So I want to text join using that from this whole array. says to include the example this time, right? Again, using more semicolons. Going to join all of these to get one long list of addresses that that count toward this hidden message. Make a new map here, map 2. Instead of this, I only want to see the ones that I want to see. Which ones do I want to see? Well, let's see. X text split this by this. Like that. Yeah, you can't do that in Excel, right? X text split is just one, like that. Okay. So now exists. The array is here. That array exists, and then the value, but it's got to be locked, of course. The value is going to be the address of the row and the column in a relative style, right? So if it exists, then I want to see the actual pipe from here. Otherwise, I want to see nothing. So only show me the pipes that existed. And there we go. Summa cum laude graduate, with greatest honors. Something like that. I don't even know what that means. I should probably have looked that up. I know how to spell it though. Graduate. All right. Now, how many pipes connect to other pipes? All right. Boom. Let's do it. We should probably start with this. I'm gonna make a new sheet for bonus 4. I still call them 1, 2, 3, 4, even though they're really A, B, C, D. I'll probably switch that at some point. All right, so these things here are all gonna be relevant in bonus 4. I care about the address, care about the pipe. Now I need to go up, down, left, right, which I have already in arrows, right? To row, let's say. So now arrow move from here, making that move, locking that and locking that. Okay, so now I can just, X lookup back on the same thing again. Back lookup here, returning there. Okay, and this has got to stay locked also. And if there's nothing, there's no cell above the top left cell, so I'm not worried about it not matching, but I'll handle the errors there. There we go. This looks right. Just save this, make sure it doesn't crash Excel or anything. Oh, I gotta get rid of data tables. Cannot have extra data tables open if you want to go fast. Oh, I deleted the formula there, which I didn't mean to do, but that's fine. I don't need it. All right, so now that I'm a little faster because I got rid of my data tables, I can fill in the rest of this. So now I need to know some things, right? So I'm going to make another let here, right? And I'm going to say, so there's a pipe A, which is going to be that, right? With the column locked. Then pipe B is going to be, well, that's not a pipe, that's an address, by the way. That's pipe A. Pipe B is going to be this one with nothing locked because it can go wherever it wants. Then the direction is going to be something. I'll get back to that in a second. All right, so let's say the directions are 1, 2, 3, and 4, right? For up, down, left, and right. I think that's what I want, right? So now the direction is $G $1. So now I've got that number, right? So that's the direction, or the direction index at least, even if it's not an arrow, but it's what position it is. Up is first, down is second. So now I need to know the connections for A, which is XLOOKUP pipe A on the pipes returning 2, and if it's missing, we'll just call them zeros. So that's good for the connections for A. Connections for B are going to be similar, but it's based on pipe B and the from. So now what I need to know is the first one of these or the third one, whichever direction I'm looking at, the first one of these and the first one of these both have to be good, right? So now what I want is like the minimum, right? It's an and, right? It's a minimum. So the minimum of the mid of connection A direction 1 and connection B direction, not 1, but direction, direction, and then one character. That is the end of the minimum, and that's the end of the let. So the maximum of these, because I just need one connection that works, right? So this one, like, does this one go to this side and connect to there? Yeah, I think so. The sum of all of this is 1504. Boom. All right. Thank you for watching. Bye.